All right, I'll give you a couple more seconds, and then we'll go over it. All right, so remember this question was essentially about paying off student debt. So she started with 66,000 and was paying off the 1,010 a month. So we got that equation last time, the 66,000 minus 110t. So we wanted to find the intercepts and interpret them. And I think technically the y value is technically called d. So let me bring that back in here so I can say that intercept. Will you finish drawing the letter, please? Pen? My laptop seems cranky today, which is going to be full of fun. It's very angry right now, actually. That's not good. Oh my. That's not good at all. Great. Try one more thing before I have to switch to something else. All right. One moment. So if you haven't finished it, go ahead and finish that. Apparently it decided to be happy now, but I'll keep getting my other option together just in case it gets angry again. I haven't heard of a GroupMe for this class yet, but if anyone knows of a GroupMe or wants to start one, someone in chat asked. All right, so let's go over this question. So remember, we have two intercepts. We have a t-intercept. I muted myself. Yes, we have a t-intercept and a d-intercept. So I'm going to go ahead and find the t-intercept first. I'm going to go through this slightly fast since you already should have attempted it. But as always, if you need me to slow down or go over something better, just let me know. So the t-intercept, we're going to let d equal 0. Remember, whenever you want to find one intercept, you set the other value equal to 0. So I would add the 1100t over to the other side. Divide by the 1100, t will be 60. And actually, I'm going to do the interpretations over on the side. So let me just find the two and then I'll interpret them. So you should have found that your t-intercept was 60. And since t was in, I believe it's months. Yes. So this would be 60 months. And then for the t-intercept, your t value is going to be 0. So we'll have 66,000 minus 1100 times 0.
Involved the step only. What is a movement or some sort of activity that is?
So 66,000 will be our d-intercept, and that was in dollars. So let me just write dollars at the back. And then when we interpret the two, remember these are two completely separate entities, so you need essentially two different sentences, one for each. So I'm going to start with the d-intercept first, actually. So essentially that will be before, that's supposed to be a B, not a D, before paying anything, before she starts paying, 0 months since she's been paying. Before paying anything, Kayla has that $66,000 in loans. So that would be for the d-intercept, essentially time 0, $66,000 She's been paying it off for 0 months, so essentially before she starts paying it off. And she's got the 66,000. And then for our t-intercept, the time is 60, but the d value, the amount is 0. So that's essentially going to be the amount of time it takes for her to pay them off. So I would say something like after 60 months, Kayla will have paid off her loan. Now again, with these interpretation pieces, as long as you're getting the point across, I don't really care how you phrase it. If you wanted to say after 60 months, Kayla will have a balance of $0 on her student loans or anything like that, as long as it gets the point across that it's been 60 months and there's now $0. And for the first one, 0 months have passed and she's got $66,000 in loans. Questions, concerns about that warm up? All right. Before we get into finishing the notes, I just want to make a note really quick because it came up today in Teams, and I just want to make sure. Over there. So just be really careful when you're joining Teams. Now, it's perfectly fine because I know some people are new to Teams. Don't hit this meet button up here in the right corner. Don't click on that because that'll create a new meeting. This one still says I'm in there, even though I'm not. But so it'll create a new meeting instead of allowing you to join the meeting that's already been created. So if you're like the first one here, you'll need to like click on the little purple bit because it won't say join yet, and make sure it's actually on the one that says class sessions. Because this specific meeting, the difference is that this meeting has a bunch of options set up specifically the way I want them, and new meetings will not. So just be kind of careful about that. And so hopefully this will disappear eventually, but because I'm not in there, and hopefully that other person moved too. But anyway, just tidbit. Just be careful if you're the first person around and it hasn't started yet, that you're making sure to start in the right place. But if you've never used Teams before, totally understandable. All right, let's finally finish this first set of notes, and we're probably going to move on to our next set as well. So the next set of definitions is for increasing, decreasing, and constant. So a function is increasing if the values of f of x, so essentially the y values, are increasing. Imagine that. As the values of x increase. So, we've got a couple options. You could just have a straight increasing line. It could kind of slope a little bit in a couple different directions, as long as essentially the y values are getting larger as you're moving from left to right. Function is decreasing if the values of f of x are decreasing. As the values of x increase. It's still increasing the x values, so that's an important bit. So we could go, just straight down. We could also curve a little bit in a couple different directions. That's increasing in a couple different ways. As long as essentially you're going down in y values, your y values are getting smaller as you move from left to right. And then we've got that a function is constant if the values of f of x are constant as the values of x increase. So the values of f of x are constant as the values of x increase. And that you kind of just have one option, go straight across. So in all of these cases, we are looking at when the x values are increasing. So if your x values are doing different things, you need to make sure to kind of rearrange them into an increasing pattern to be able to figure out whether it's increasing, decreasing, or constant. Yeah, if you prefer, instead of using f of x, if you want to use y, those are pretty much kind of synonymous in a way. Synonymous in terms of math terms. So whenever you see f of x, if you prefer to say y, you can do that. It's the same thing. All right, so wait a couple seconds so Y'all can make sure to get that down. Oh, actually, I think I've just realized what you said. You might be talking about this one here. We can't change this one to a Y because it's specifically this piece in the back is telling us that we're moving from left to right. So that specific one has to be X in each one of these because the thing that we're looking at is what the Y's are doing as the X's increase in every situation. All right, so let's look at a couple of examples of this. Determine whether each table below represents an increasing, decreasing function. So in this case, we've got our, quote unquote X values and our quote unquote Y values. The H of T would be our Y values, acting as our Y values, I should say. So notice that the T values are increasing, so we're okay in that regard. And then if we look at what essentially those H of T values are doing, if we go from -8 to 0, that's going up. We're increasing by 8, we're increasing by another 8, and then we're increasing by, oh, my arithmetic's bad, some other larger value that's greater than 8. It doesn't matter that they're increasing by different values. The fact that those Y values are getting larger means that this would be an increasing function. So that function is increasing. Part B, which is the one below it, this one we need to be careful because notice for the T values, that first row, they're actually decreasing. So since T is decreasing, if we think about it enough, we could think about how that would manipulate the increasing or decreasing of the Y values. But let's just go ahead and rewrite this table. It's not a very long table. Let's just rewrite it in terms of increasing T values. So let's just essentially flop this around. Why'd I write T instead of 1? 1, 2, 3, 4. So we have 20, 15, 10, and 5. So now that we have the T values increasing, which again is incredibly important, you always need the things that are your essentially X values to be increasing to consider whether the Y, to then consider the Y values. So now once we flip this around, now our Y values are going down, 20 to 15 to 10 to 5. So since the Y values are decreasing, we have a decreasing function. So that's what it's important to not just look straight at the Y values, because if you looked at the Y values themselves and didn't look at the X's, the T's, sorry, we're using T's in this situation, you might think that's an increasing function because it goes from 5 to 10 to 15 to 20. But since we're not set up to have those T values increasing, you would have unfortunately been wrong. So part C, let's look at our T values first to make sure they're increasing. They are 0 to 2, 2 to 4, 4 to 8. Good, they're going up. So we can just immediately then look down at our S of T values. Excuse me. So our S of T values are getting larger. So, since they're negative numbers, going from -25 to -20 is getting larger. So since those values are increasing, this would be an increasing function. And then in part D, we kind of have that tricky situation happening again where T is decreasing. Now don't assume that just because T is decreasing, it's going to be a decreasing function, because this is also going to turn out to be a decreasing function. That's not always the case. You could have T being decreasing, you have to flip-flop it over, and all of a sudden it turns into an increasing function. Well, it doesn't magically change it to an increasing function, but you can then tell that it's an increasing function. So let's go ahead and switch this table around again to have the T values being increasing. So we'd have 20, 15, 10, and 5, which again, since those M of T values are now in the correct order and they are decreasing, this would give us a decreasing function. That doesn't really look like an R. So again, once you have seen enough of these in your life, you don't necessarily have to rewrite the table if you can just think about it. Since the T values are decreasing and the M of T values are increasing, it's essentially going to be opposite. So since the M of T values are increasing, but the T values are decreasing instead of increasing, then it would tell you that it's essentially flip-flopped. Since the M of t values look like they're increasing, but the t values are in the wrong order, then it would be a decreasing function. Hopefully that made any sense. If it didn't, just make sure to always rearrange it to have the t values increasing, and then just look whether it's increasing or decreasing. Questions, concerns about any of those? And then I'll hold on a couple seconds before scrolling down. So there's kind of two things you have to consider. You have to make sure the t or the x or whatever variable you're working with, let me put or there so that doesn't look like t of x, is increasing. That's the first thing. You always want those to be increasing, because if we go back up here, all of the x values had to be, whoa, I didn't mean to do that. All of the x values had to be increasing before we could consider the definition. So that's the first thing to look for. And then from there, you determine, so let me kind of bullet point this, determine if the, f of t or f of x or whatever function name you're working with, we had a bunch of different function names here, are increasing or decreasing. And it's this is essentially your answer. Move that bar over a little bit. There we go. So there's kind of two things to look at. You have to make sure the t values are increasing, but then to actually answer the question, it depends on what's happening with the f of t values. If the f of t values are there and increasing, then the function is increasing. If the f of t values are decreasing, then the function is decreasing. That makes sense? Okay. So I'll hold on like 5 more seconds just in case someone's still taking something down. We've got one more question in this set of notes, and I'll talk about the things at the end. But anyway, we've got one more official question here. So on what intervals are the following functions increasing and decreasing? So one thing I kind of need to side note real quick before we answer this question is interval notation. Say I wanted to say, I was between two values and I could actually be equal to those two values. Another way I could write this is in an interval with brackets. So essentially, if I wanted to say an x value between 1 and 3, and you could be equal to 1 and be equal to 3, then I would have bracket 1 comma 3 bracket. If I want an interval between two numbers, but I'm not equal to the last two numbers, I'm not equal to the endpoints, that would be in parentheses. Now I know that that looks like a coordinate point. The context of the problem is going to clear up whether or not it's a coordinate point or an interval. And then you can also have kind of a half and half situation. So it could be equal to one end but not equal to the other end. Essentially, whenever you're allowing when you're allowing it to be equal to that endpoint. Oh, my laptop get angry. 1 second. And should be back. Oh, is it going to be really obnoxious for a second again? There we go. So essentially, the endpoint that you're allowing to be equal to, the one with the equals, is always going to get the bracket, and the one without is always going to get the parenthesis. So you can also kind of have like a half and half situation. And that's essentially what we're going to use to answer these questions. We're going to answer these questions in interval notation. So hold on a couple seconds for you to write that down. So in this first one, so we want to, now of course these could change. So we want to look at from left to right. Always make sure that you're reading these graphs from left to right when you're talking about increasing, decreasing. Yeah, go go up for a second. So when we get back to that one in a second, always look from left to right. If you, oh, more up. If you don't look from left to right, you're gonna get it wrong. Let me know when you're good. Cool, thank you. All right, so in this first one, as we move from left to right, I'm starting to, my y values are going up, they're going up, they're going up, and then at this point, it's essentially going to change and they're going to start going down. So essentially, I'm going to have to break this up at that point there. So notice also, very important point, intervals are in terms of x values, always. Well, in terms of our class, always. There are situations where they could be in terms of y values, but for our class, we will always write intervals in terms of x values. So essentially, this is going to stop and change at x equals 1. So we're going to have an increasing section and a decreasing section. So it's increasing essentially from the very back of the function all the way up to x equals 1. So since there's these little itty bitty arrows at the bottom of this function, that means it continues forever. So it's actually going to go all the way back to negative infinity. And then we're going to go all the way up to positive 1. Now, this would also be an acceptable answer. So one thing, if you ever have an infinity, it never gets a bracket. Never put a bracket on an infinity. Infinity is technically not a number, it's a concept. So you can't say you're equal to infinity. That doesn't make sense. But the reason we can either leave it open or close it is because saying that a function is increasing or decreasing at a singular point doesn't make any sense, and actually it's not defined for single points. So I can include that x equals 1 in the interval, or I can leave it out. I usually just leave them out. So this is the one that I would usually write, but technically the other one is correct as well. So I'll write them both. Now for the decreasing piece, we start at x equals 1, and then we essentially continue on for the rest of the graph. So this would start at 1 and go all the way to infinity. Again, you could technically include 1 if you wanted, because it doesn't make sense to be increasing or decreasing at a singular point. So it is okay even if you include it in both of those intervals. Again, I usually just leave it out, but whatever floats your boat. Now for the second one, you need to be a little careful. Notice that there's a difference between these 2 points. Let me super zoom in real quick. This one right here, I'm going to say is blank. It's not filled in. It's a white circle, if you will. It's just like the outline. Whereas this one down here is filled in. So essentially the difference is that we have, if you will, x equals 2 over here. So like that function actually goes to x equals 2. But we don't have x equals negative 2 because that circle is open. So it essentially gets as close to negative 2 as possible, but we just don't actually have a value for negative 2. So what that's going to do to our interval is it's essentially going to tell us whether or not we include that number in the interval. So notice that this function, as we move from left to right, it's essentially going down always. Now it gets a little bit, it would be constant at exactly this singular point if that would make sense, but that doesn't make sense. So we're just going to say that it's decreasing the entire time. Like I know it kind of looks like it slopes off to be constant right there, but again, being constant at a singular point doesn't make sense. So we're just going to say this is a decreasing function for the entire time. So let me try to block this off. So we are decreasing, my C got messed up, from -2, but not including -2 because it's an open circle. And we go all the way up to +2, but we include +2 because it's a closed circle. So you won't see too much of that. In our class, we don't necessarily deal a lot with the open circle and closed circles, but if they do appear, you might have a question or two maybe on your homework for this section. That's how they would go. Open circles are not included, closed circles are. Questions, concerns on that one specifically? Or the first one? Okay. Okay. This last one, moving from left to right, we're kind of going up, we're going up, we're going up, and then here at x equals 0, we're suddenly, our y values are suddenly getting smaller as we move from left to right. So we are going to have an increasing piece and a decreasing piece. Now this also has the little tiny itty bitty arrows at the end of both sides, so this is going to continue off forever. So we're going to have infinities in this one. So from that first side, let me just finish this one and then I'll answer that question. So from the left side, we're going back to -infinity and all the way up to x equals 0. And that's going to be our increasing piece. Again, you could include this if you wanted to and make it a bracket. Again, I usually just make it all open, but whatever floats your boat. And then from 0 onto infinity, it would be decreasing. And again, you could make it a bracket on that 0. So I'll just write them both out. Both would be acceptable answers. So someone asked about the last one, if the points in the second one were filled in, so say this one in the back was also filled in, it was a closed circle, then yes, it would have been -2 to 2, both bracketed. But since that one in the back at -2 was open, it would be open. So if both of them were open, if this one over here wasn't closed and it was just an open circle, then it would have been a completely open interval. So if it's an open dot, it gets a parenthesis. If it's a closed dot, oh no, it gets a bracket. Any more questions? Any pieces of that question? Okay. I'll leave this up for a couple of seconds. Well, actually, I'm going to scroll down really quick and then I'll scroll back up in a second. So if you notice, if you have this in front of you, there's some extra problems on here. That's probably it's mostly gonna show up in every single section. But since they're extra and we're not going to take the time to do them because we're already, imagine that, we're already slightly behind schedule, but it's all right. But I do fill them out. The answers will be on Blackboard today if you want to go through them. You don't have to. But especially in certain sections, if you're like, I should do a little extra practice on those, there will probably be a couple at the end that you could try to do, and then check your answers on Blackboard. But technically, we are done this set of notes for what we needed to cover. And those ones pretty much cover the same material that we went over. The only thing in here is that it talks about the vertical line test. This is not a necessary thing. You can technically answer those questions and answer questions that I would ask you without the vertical line test. But the vertical line test is kind of like a cheat sheet way to do whether or not a graph is a function. All right, but otherwise we are moving on to our second set notes on linear functions. Now, technically there's this warm up here, and actually I think I'm going to leave that for next time. So we're just going to start off with our definition. So wait a couple seconds in case people need to pull that up real quick. So in the section we just finished, we talked about functions in general, and now what we're going to do is we're essentially going to start looking at specific types of functions. So we're going to start with a specific type of function called a linear function. So we have that the definition of the slope between 2 points is calculated by the following. So sometimes you'll hear it as rise over run. I will usually not call it that, but if you like it, go right ahead. There's a delta y over delta x, and I'll talk about that little symbol in a second. But the way the real way we calculate it is this y2 minus y1 over x2 minus x1. And it's essentially the slope between 2 points because you're given some point x1, y1 and x2, y2. And this was actually one of your diagnostic questions that I think most of you got pretty much right. So this little delta essentially just means change in. I don't know why it's writing all the way over there. So you'll often hear me probably say change in y over change in x, and that's what I'm referring to. So a linear function can be put in what's called slope-intercept form. That's going to look like this. Y equals mx plus b. There's also a different type of setup. And actually, I talk about that later, so I won't write it down here. But if you know the word when I say it, if you know point slope form, and I'll write that down later, but I find most people usually use this one. But if you know point slope form and you prefer it, go right ahead. So the graph of a linear function is a line where the m value in that equation is going to be the slope, and the b value in that equation is going to be the y-intercept. Or maybe I should be better and say vertical intercept. So a linear function essentially has a constant slope. So if a function has a constant slope, then you know it's linear. Which is essentially what this first patch of questions says. Determine whether the following tables could represent a linear function. If it can, find a possible formula for the linear function. If not, explain why not. So I'll hold on like 5 seconds in case any of you are still writing down the definition, and we'll go through those. One thing I should say about slope is it doesn't matter which point you make x1, y1 and which point you make x2, y2. You will get the same answer. The only thing you need to be super careful of is being consistent. If you put a certain y value first, you have to put its associated x value first. So that's the only thing you have to be careful on. Otherwise, it doesn't matter which point you make which. So if we look at these tables, if we want to figure out whether or not they're linear, there's a couple ways we can do this. I personally like to do this little I call it a loop way. I don't really know why I call it a loop, but essentially what I do is I look at the changes in the x's. So essentially I'll look at this table and I'll say, okay, between these two x values, between 0 and 100, that goes up by 100. And then between 100 and 200, that goes up by 100. And then up by 100. And then I'm going to see what happens between all of these y values, these g of x values. So between 25 and 50, we go up by 25. You don't really need to put the plus if you don't want to. We go up by 25, and we go up by 25. Now, the thing we would need to look for to determine whether or not this would be linear is if all the ratios of the change in y over change in x is constant. So maybe I'll say is change in y over change in x constant. Now the change in y here would technically be a change in g of x. So remember, whenever I say y, it's also associated with the f of x, g of x, f of t, h of x, whatever the function name is. So essentially, this would be a 25 over 100, so essentially a 1/4 in every single one of those situations. We have 25 over 100, 25 over 100, 25 over 100. Since all of those ratios agree, this would be a linear function. Because all of those change in y's over change in x's agreed with each other. So since it says linear, we're asked to find the equation. So essentially what we need is we need the slope value and the y-intercept value. The slope value we've actually already found. That was that change in y over change in x. So the slope would be that 25 over 100, which reduces to 1/4. So that's going to be our m value. Now in these cases with these tables, we're actually able to pull out our b value very easily. And we'll look at a way to figure out the b value if we can't do that. But for these ones, I'm going to use that kind of cheat sheet way in a way. So remember, a y-intercept is always when the x is 0, and we're actually given the value when x is 0. So since we're given the value when x is 0, we actually know what the y-intercept is. It's 25. Again, I'll show you a way to figure out the b value if that's not the case. But for these ones, since we're given it, let's just use it. So then if my equation is y equals mx plus b, y equals m1/4 x plus our b value of 25. I realize that I might have went through that a little fast. Questions, concerns on that? I'll wait a couple seconds before going to the next one. Okay. So we'll do the same thing for the second one. So let's see what's happening between these t values. So between the first two, we go up by 5. I'm going to drop the plus sign this time. And then we go up by 3. And then you guys will also quickly learn that just like my spelling, my arithmetic is terrible. All the rest of the math in the world is great, but my arithmetic is horrendous. So if I ever tell you that 2 plus 3 is 6, correct me. All right, so just because those numbers don't agree does not mean you get to stop, okay? So we actually need to keep going. So I understand that 3 is not 5 is not 7, but we need to keep going because that might not matter. So let's look at the difference between these y values, these f of t values. So we get from 10 to 20 gets us an increase of 10. From 20 to 26 would be an increase of 6. And from 26 to 40 would be an increase of 14. So we need to check our f of y, our delta y over delta x, which in this case, now I'm always going to refer back to delta y over delta x because that's usually the way I think sticks in people's heads. So I do want to make sure to make the equivalent statement for the actual variables that were given in this problem. But if you always want to write down delta y over delta x because it helps you out, go right ahead. But technically it would be a delta f of t over delta t in this situation. So in the first kind of batch, we have a 10 over 5, which is 2. And then in the second batch, I'm going to run out of space if I don't start writing a little smaller. Let me kind of squeeze. Let me do this. So we have a 10 over 5, which is going to reduce to 2, but I'm going to run out of space, so I'm not going to write down yet. And then we have a 6 over 3, which also reduces to 2, so I could write that they're equal. And I have a 14 over 7, which is also going to reduce to 2. So actually, all of those ratios actually do agree. None of the numbers agreed with each other, but their ratios agree. They all reduce to 2. So yes, this is linear. It's got a constant slope. I didn't write that down in the last one, but that's essentially the reason these are linear. They have constant slope. So our slope value is essentially what we just found. It's going to be 2, 10 over 5, 6 over 3, 14 over 7. And then again, in this specific situation, we can find our b value very easily. My laptop got angry again. We can find our b value very easily. I'll just talk about it while it gets back to life. It's going to be when t is 0. So our b value is going to be 10. So since our b value is 10 and our m value is 2, our equation will be, now in this case, we can use y because they don't tell us any other variable besides f of t. We could also say f of t. But we want to be careful because this should be a t instead of an x. So since they tell us it's a t, we should use a t. Usually we can assume, unless they tell us a separate variable, that the function name is equal to a y value. And then plus our, I didn't write down the b value. B value is 10, plus 10. To be super clear, if this second, let me just make that go away for just a second. Say this was a t and D. If they actually give you an actual variable and not a function name for the second one, then you would want to make sure to use that variable. But since we're given a function name, we can assume any function name if we want. We don't have to. You could even write f of t if you want. But if you're not given an actual straight variable there, you can use y if it has a function name. How did we find the b value? So remember, the b is the y-intercept. And remember, to find the y-intercept, remember when you're looking for an intercept, the other value is always 0. So the x would be 0. In this case, it's a t. So we can essentially, if we're given the value at 0, we can just use the y value of that for our b value. So since we're given in the table t of 0 equals 10, that's what gives us our b value of 10. Make sense? Again, I don't think we'll get to it today, but on Wednesday, we'll talk about a way to do it when that's not given to us. But for right now, they're being given to us, so we'll just use it. So wow, we're almost out of time already. So we're on our last one. So if we look at this one now. Oh, sorry, any more questions on that other one? Oh, let me box our answer here. So here, let's look at our change in x's. So we've got an increase of 12, increase of 12, increase of 12. Off to a good start, but again, those values matching just on their own doesn't really make a difference. And then let's check to see what our h of x values are doing. So we're increasing by 20, and then by 10, and then by 5. So you might already see what's going to happen here, but just to really clarify at home, if we're looking at our change in y over change in x, which in this case is a change in h of x over change in x, we're looking at 20 over 12 versus, 10 over 12 versus 5 over 12. And I'm using a little versus instead of an equals because they're not going to be equal to each other. I don't even know what these, so you might just be able to say, since all the denominators are the same and the numerators are not, they're different. But if you need to change them over to decimals, that's also perfectly fine. Also, it might not always be super clear. The denominators might be different as well, so you might have to change them over to a decimal to see whether or not they're the same. So if we change all of these to, so this is technically 1.6 repeating. If we change all of these over to decimals, it is then very clear that those are not the same number. So this is not a constant slope. This is not linear. So not a constant slope. So this is not a linear function. Questions, concerns on that question? Okay. So 2 minutes is not enough time to go on to the next one because it's got 2 parts. So we're going to stop there. Didn't get too far in these notes, but it'll be all right. So we'll continue on with these notes on Wednesday. So there's no classes on Monday, MLK Day. So sleep in, have a great time or something. I don't know. So we don't meet on Monday, but we will meet on Wednesday, which also means that you have a quiz the next time I see you. So what I'm going to do in chat right now is I'm going to type out your quiz on Wednesday. So usually I would tell you this on Monday, but since we don't have class on Monday, I'm telling you now. Your quiz on Monday will consist of questions concerning like, is this a function? So we'll also, kind of start with a warm-up next time of some questions that are, is this a function? And if you want some practice before that, there is one of the extra questions in the first set of notes. Is this a function or not? So you can also look over that before Monday before Wednesday if you want. And then the other thing I will ask you is a table, or should I say set of data linear, which is essentially the question, We just did. So those two types of questions, is this a function and is this linear, will show up on your first kind of official quiz on Wednesday. So that's in chat. You should be able to come back to Teams and look at chat later if you've forgotten, but that will be on Wednesday when I see you next. Otherwise, also just your first official homework set will be popping up on Monday. I know we don't have class on Monday. You don't have to start it. But they're going Monday to Monday, so it will appear on WebWork on Monday, and you have until the next Monday at 11:59 p.m. To complete it. So I'll be putting that up, and that will go live on Monday, and you'll have all week to go through that. All right. If you have questions, feel free to stick around for a little bit. Otherwise, have a great weekend. I will see you have a great long weekend, and I will see you on Wednesday.
Miss Hannah.
Yes, you had a question.